In this video, we are just going to do some practice problems going over LeChatelier's principle. So let's start with this reaction. I know we've used it a few times. Nitrogen plus 3 moles of hydrogen produces 2 moles of ammonia. And let's also say that you're given the change in enthalpy, delta H, for this reaction, and it is a negative 92.2 kilojoules. First question. Concentration of H2 is decreased. Equilibrium shifts blank, and the concentration of N2 blank. Alright, so we stress this reaction by decreasing the concentration of hydrogen. The way that we restore equilibrium is by producing more hydrogen. Well, if I want to produce more hydrogen, it is going to shift to the side that hydrogen is on. Equilibrium is going to shift left. We could also use our saying, if we subtract, it stays. So if I am subtracting hydrogen or decreasing hydrogen, equilibrium stays to the side that hydrogen is on. Hydrogen is on the left-hand side, equilibrium shifts left. So now the reaction is proceeding this way. That means ammonia is getting used up. We're going to break ammonia down in order to make more hydrogen. But in the process, we also make more nitrogen. Concentration of nitrogen increases. Question B. Temperature is decreased. Equilibrium shifts which way? So now we have to think, where is heat going to go? Delta H is negative. That means this is exothermic. Heat is being released. So if heat is being released, we're going to think of heat like a product. It's being released or being produced. So if I decrease the temperature, the way that I restore equilibrium is I need to increase the temperature. In order to increase the temperature, it has to shift to the side that heat is on. So equilibrium is going to shift to the right. Pressure is increased. Equilibrium shifts which way? So remember, when we're talking about pressure, we're talking about moles of gas. So on the left-hand side of the arrow, I have 1 mole of nitrogen and 3 moles of hydrogen, which gives me 4 moles of gas. Over here, I just have 2 moles of gas. So if pressure is increased, that means volume decreased. They're inversely related. If pressure goes up, volume goes down. If I have less space, it's going to shift to the side with less moles of gas. So equilibrium shifts right. Let's try another one. Let's look at a new reaction. First question. The concentration of oxygen is increased. Equilibrium shifts in which direction? The concentration of phosphorus trichloride increases or decreases. If I increase the concentration of oxygen, the way that I restore equilibrium is by using oxygen up. Well, to use oxygen up, it has to shift to the left. We could also use our saying, if you add, it goes away. Oxygen is on the right-hand side. If I add more oxygen, it goes away, it shifts to the left. Well, as this reaction shifts to the left, I am using up oxygen, but I'm also using up phosphorus trichloride, so its concentration decreases. Question B. The concentration of phosphorus trichloride decreases. The forward or reverse reaction will be favored. Alright, so now I'm decreasing the concentration of phosphorus trichloride. To restore equilibrium, I need to make more phosphorus trichloride. So it's going to shift to the right. If the reaction is going to the right, that is the forward direction. If you add, it shifts away. If you subtract, it stays. If I'm decreasing it, it's like I'm subtracting it. It's on the right-hand side. Equilibrium shifts to that right side. If it shifts to the right, it is the forward reaction that will be favored. C. A catalyst is added. Equilibrium will shift which way? Trick question. A catalyst increases the rate of the forward reaction and the rate of the reverse reaction by the same amount, so it does not cause a shift in equilibrium.
New reaction. Sulfur dioxide plus oxygen produces 2 moles of sulfur trioxide plus heat. So this is an exothermic reaction. List as many ways as possible to increase the concentration of sulfur trioxide.
All right, let's think about this problem. We haven't really done one like this so far. So we are not stressing the reaction. Normally, I tell you the concentration of something has increased. In this case, we want to figure out how do we need to stress the reaction. I want to make as much product as possible. So we need to think, how can I stress this reaction in order to increase sulfur trioxide? Which way does equilibrium have to shift to produce more sulfur trioxide? Well, it's on the right-hand side. So if I want to make more, it must shift right. That is the most important thing to figure out. A lot of students will say, well, if I'm increasing, it's going to shift away. It's going to shift to the left. The problem is not saying that we're adding more SO3. It says we want to make more SO3. So in order to make more sulfur trioxide, it must shift to the side where it's being produced. It has to shift right. Well, now that we know that it must shift right, let's figure out all the ways that we could force equilibrium to go right. Well, if I add, it's going to shift away. So I can increase the concentration of sulfur dioxide. If I add, it shifts away. This should make sense. Think of it in terms of something other than a chemical reaction. Bread plus cheese produces grilled cheese sandwiches. I want to make more grilled cheese sandwiches. Well, I need more bread and I need more cheese. Increase the bread, increase the cheese. It is the same exact thing, just with chemical formulas. So we can shift reactions by changing concentration. Let's talk about temperature. Would I want to increase or decrease the temperature to shift it right? Well, if I wanted to shift right, it is going to produce more sulfur trioxide, but it's also going to produce more heat. So that means the way that we force it to produce more heat is by decreasing the temperature. If we decrease temperature, we restore equilibrium by producing more heat. It's going to shift to the side where heat is being produced. Lastly, let's talk about pressure. 2 moles of gas plus 1 moles of gas. 3 moles on the left, only 2 moles on the right. So we want to force it right. we want to force it to the side with less moles. That means it's going to be less space. So in order to force it to shift to the side with less space, we could decrease volume or increase pressure. If we increase pressure or decrease volume, we have less space. It's going to shift to the side with less moles of gas. Let's look at one more reaction. We'll do a few more examples. Endothermic reaction. All right, I'm going to make a little table. So we're going to talk about the stress. Let's first talk about the shift. Will equilibrium shift to the left or right? And then tell me what happens to the concentration. Let's pick nitrogen. First stress. Increase temperature. Let's decrease the concentration of oxygen. Let's increase the concentration of nitrogen monoxide. We'll add a catalyst. Let's increase oxygen and increase pressure. All right, temperature is increased. If we add, it shifts away. Heat is on the left, it's going to shift away. It's going to shift to the right. Thinking about it in terms of LeChatelier's principle, if I increase temperature, we reduce the stress by decreasing heat. It's going to shift to the side that heat is not on. If this reaction is going to the right, reactants are getting used up. So concentration of nitrogen is going to decrease. B, if I decrease oxygen, that's like subtracting. If you subtract, it stays. Oxygen is on the left, equilibrium shifts left. So now, if the reaction is going to the left, NO is breaking down to produce more oxygen to restore that equilibrium, but it's also producing more nitrogen. So the reaction of the concentration of nitrogen would increase. All right, if I add, it shifts away. It's going to shift left. Again, if I'm favoring the reverse reaction, it's going left. The products are breaking down, you're making more reactants, concentration of nitrogen will increase. Adding a catalyst. Trick question. No shift in equilibrium. If I increase oxygen, if you add, it goes away. If I add oxygen, the way I reduce that stress is by using it up to make more product. If I add oxygen, it shifts to the right. So I'm going to use up oxygen and use up nitrogen. So the concentration of nitrogen would decrease. Last one, we increase pressure. Pressure depends on the moles of gas. On the left side of the arrow, I have 2 moles of gas. On the right side of the arrow, I have 2 moles of gas. If I increase pressure, I decrease volume. If I decrease volume, that means I have less space. It's going to shift to the side with less moles of gas. But wait, they're exactly the same. I don't have a side that has less moles of gas. No shift. So we could just leave that column blank.